Okay, good morning everybody. Happy Tuesday. How did the homework go? That's a quick scroll around the room. Saw quite a bit of good work, and then I saw a couple people with answers only, so they're prodigies. Remember, I'm doing the note card thing. So the first name on the top is always the one that gets to get put at the back. So Christian, your name was the very first one. It goes to the back. You'll be the last question asked, if I get that far. Cool? All right, questions about the homework that we should go over. A couple of you said, hey, I had problems with this or that, so let me know. What do you got? Yo, George. Number 8, there and there.
No, number 9.
Number 9, sweet. Next. 7x plus 15y equals 32. And then x equals 3y plus 20. So solve the following is by either substitution or elimination. Megan, you're on my question. Okay. Do you feel, by looking at this question, it'd be set up by elimination or substitution? Why would you feel that? I think you're absolutely right, but why do you feel that way? Absolutely. So we know that our relationship with x is equal to this, as far as the other equation goes. So what I'm going to do is I'm going to take that and I'm going to plug it into the first equation. So this is how substitution works nicely. Again, the elimination is if it's all set up with x and y on the same side, and you're not able to figure out x or y. So I'm going to take that top equation. Okay. So Andrew, I had an x there on that first equation. What should I put into those parentheses now? There you go, 3y plus 20. Very good. Okay? Does everyone see that little exchange? Preston, is that okay? I know it's kind of new. You haven't seen that before. Okay, Stephen, coming to you now. What should I do with the 7 in relationship to the new red equation? What should I do with the 7? There's parentheses in front of it. Distribute. Distributes multiplication, right? So multiply it here and here, so I'm going to get 21y plus 140, and then that plus 15y comes down for the ride, and the 32 also comes down. So what substitution does is it takes us from having 2 variables, you substitute one into the other equation brings you down to 1 variable, and then you can start solving it. Let's see, George. Do I have any like terms on this equation up here right now on the same side, on the left side? What would that be?
21y.
There you go, 21 and 15y. I'm going to combine those together. They're both positive. So that's going to give me 36y, I believe, plus 140. That's equal to 32. If I start working this out, I'm going to subtract. Somebody have a calculator out by chance? 32 minus 140, somebody? How much? Negative 108, thank you. Don't forget the negative. And 36 and y are being held together by what property? It's being held together by multiplication, so I'm good. Divide. There we go. Negative 3. Okay, so my y value is equal to negative 3. Okay, so if my y value is equal to negative 3, Mackenzie, what should I do with that negative 3? What am I trying to solve for now that I have a y value? I'm trying to solve for an x. Where should I plug that in order to get an x value? Yep, absolutely. So this is a y value right here. Now, it can be plugged into either of those. Mackenzie said the second one. Why would the second one be a good one, Sophia? It is just easier, but why is it just easier? What letter am I trying to solve for? X. And that second equation is x equals, right? So I'm going to take that and I'm going to plug it in. And it doesn't matter which one I plug it into, but I'll plug it into the second one. So I'm going to get x equals 3, parentheses, plus 20. Sophia, excuse me. I had a y there. What am I going to put in place of it now? Negative 3. Very good. And just a reminder, guys and girls, if you have your cell phones, have them off on your desk, please. And And then that's my x component. So if I had graphed these lines, it would have crossed at 11, -3, which might have been tougher to see because it might have been off our grid, because a lot of our grids are usually +10 to -10 in both the x and y directions. So this would have been off our graph a little bit. Also, I don't know if either one of those would have graphed nicely using the cover method. On the top one, I would have found across the x component at 32/7 and the y component at 32/15. Those might not have been real good to graph, and the second equation is definitely not given up to us to look to be a nice thing to do with the cover method. Okay? What other questions we have on this up here? Yeah, Matt.
I'm just kind of confused how to get, if there's like x, like 5x plus 6x or 6y, how to get x by itself or y by itself.
Okay. Do you have one in mind that?
Yeah, question 6.
Question 6? Okay. Okay. So on these it says use the elimination method, right, Mac?
Yeah.
Okay. So the elimination method, we're not going to try and get x or y by itself. Okay? What's going on, TJ, Angelo? I don't know what the... Just get... Oh, okay. And a muffin ran off on accident. All right, Gabe, coming to you. All right, we're using the elimination method. So first question I want to figure out, take a look at my x values. Are they both the same sign or the opposite signs? Same sign, okay. Take a look at my y values. Are they the same sign or opposite signs? Same sign. Does everyone understand when I say that, when they're both the x's have the same sign? Yeah. I have +2x and +5x, and the y's are +4y and +7y. They're both the same exact thing. Okay, so that's the first thing. So what I have to keep in mind is if I have to multiply through by a number, I need to make sure it's a negative number on one of them. Does that make sense? Yes. Everyone with me? Okay. Gabe, still with you? Would you like to get rid of x or y? It's your choice. Okay, Gabe chose to get rid of x. He's not choosing it because you wanted to do y. That just popped to his mind first. Okay? Garvey, we're going to get rid of our x's first. Still with me? Okay? And what I have to make sure I do is I have to make sure I multiply one of them by a negative to get opposite values. You still with me there? Okay. Is there a number I can multiply only one of the equations by to get opposite values with the other equation? So I have a 2 and I have a 5. So is there a number I can multiply by 2 to get to 5? That's not a decimal. No. Is there a number I can multiply by 5? Multiply 5 by to get 2? That's not a decimal or fraction. No. So this one I have to multiply both. Okay. Here's our decision. We're going to multiply both equations in order to get opposite x values. We're getting opposite x values because Gabe chose to get rid of x, which is great. I want you to tell me, top or bottom is going to be the negative. Your choice. Top, okay? So the top I'm going to multiply by a negative. Still with me? Okay. What's the smallest number, Garvey, that both 2 and 5 have in common? 10. Agree?
Yes.
Okay. So, if 10 is going to be Ben, what would I have to multiply the whole top equation by to make this be a -10? -5, we have the negative already in place. And Ben, what do I have to multiply this one by to get this to be 10? 2. So I'm going to distribute twice. So on the first equation, I distribute here, here, and here, which is going to lead to -10x minus 20y equals -40. And then distribute here, here, and here. And I'm going to get 10x plus 14y is equal to -14. Ben, in your opinion, if I add the new red equations together, would a value fall out?
Yes.
What value would that be?
X.
The x falls out. Is everyone with us? Okay. So I'll cancel those out. I combine negative 20y and 14y. I think very little. Cool. What's negative 20y and 14y combined together? Negative 6y. And if I combine these two together, I get negative 54. And then divide each side by negative 6, and I get y equals 9. Okay. Still with me? That's all that matters to me. TJ,
Yes.
what value did I just solve for?
Y.
I solved for a y value. Okay? That's a y value right there. I want to get a what value? X. So I have to pick one equation or the other to plug into. So that y value can plug in here, or it can plug in here. It doesn't look like either of the equations is already set up to solve real easily to get an x value. So your choice. Which one? Top one. So we're going to take the top equation, which is 2x plus 4y. This is our original top, equals 8. I'm going to plug, this was what? It was what? Y. What is it going to be? 9. Okay, let's do the math. 2x plus 36 is equal to 8. Subtract 36 from both sides. Looks like I have 2x is equal to negative 28, I think. And then x is equal to negative 14. Okay, so that's okay. So do you agree with me that this was the original top equation? Okay, so then I made parentheses because I found that y is equal to 9. Right? So what I'm going to do is that y is being 9, so I'm plugging in here. This is the value I wanted to plug in for, which I knew was this, because I solved it. And I had to pick one, either the top or bottom to plug it into. So I always chose to do the top. And so this y and 9, I plugged it in, substituted, and then worked it out. So this was a y, but because I solved originally that y is equal to 9, I can substitute 9 in for the. Does that make sense? Okay. Would this been an okay one to graph? Anybody? It might have been okay. I mean, the top equation would have graphed easily. X would have been 4, y would have been 2, and so I could have graphed that line. But look at the cover method on the second one. I would have had my x value being negative 7/5. That's not as nice to graph. My y component would have been fine, giving us negative 1. So I would have had one fraction on the line. It might have been okay. The reason I might have say might not be perfect is because usually when we have grids on tests and quizzes, it goes from negative 10 to positive 10, and this happens to the intersection would have taken place at negative 14, 9. And then being the negative 14 might have fallen off the grid. So this might not have been the best one in a graphing. But again, you understand I'm trying to steer you away from graphing, but I'm still trying to respect graphing as something that's a picture to look at. What else do we have to take a look at as far as the homework? And again, we only did 1 through 9, correct? Go ahead, Angelo. Number 9, go ahead. 7? All right, can I clear this?
TJ.
What? What did I do? What happened? Okay, 7. Okay, Casey. The directions for these problems says solve the system using substitution or elimination. One key for substitution is we need to have a variable either solved for or easily solved for. Do you feel we have a variable solved for right now on either of those equations? Which one? Yes, that's correct. So we might choose to use substitution on this problem because we know y is equal to this. So Casey, what do you feel I should do with that first equation in reference to the second equation? Substitute it in. I like it. Thank you. Very good. So this portion is going to go right here. So again, I know that 2x minus 3, there was a y there. But what's going to go in place there now, Casey? Perfect, 3x minus 1. Now, guys and girls, a big error that's made a lot of times with distributing is you forget to bring the negative along with it. Do I have a negative number being distributed up here?
Yeah.
And what is my negative number being distributed? Negative 3, very good. So that's going to be distributed here and here, so I get 2x. Make sure you watch the signs. I got negative 3 times 3x is negative 9x. And negative 3 times negative 1 is positive 3. And I get that to be equal to 10. Do you agree with those signs? Ray, does that look okay? Get it all right? Ray, do I have like terms up there? On the red? Yes, what would they be? X. So these are my x's. So what do I get if I combine those together, Ray? That's correct. Let's solve that. I'm going to subtract 3. So I get negative 7x is equal to 7. Divide each side by negative 7. A lot of folks like to just ignore the negative sign. They think it's a shameful thing. No, it's okay. So I get negative 1 as an x value. So Ray, I solved x being negative 1. What value am I looking for? I'm looking for y. I can plug that x value into this one or this one. Do you feel the top one or the bottom one would be better? Top. Why would you feel that way? Yeah, it's straight away. I like that language. Good deal. It's straight away. You know that the top equation is y equals. So if I take this equation, I'm going to go y equals 3. Angelo, I found that x equals negative 1. Still with me? I had this first equation. There was an x here. But what do you feel I should plug in? Not y. No. What do I know x equal to?
X is equal to negative 1.
Negative 1, and that's where negative 1 goes, right there. Okay? Negative 3 minus 1 is negative 4. This one might be an okay one to have graphed. You can graph y equals 3x minus 1 pretty easily. The cover method on the second one, you get an x value of 5. You get a y value of negative 10/3, which might not be the best to graph, but it might have graphed nicely because it is within your positive negative 10. Do we have any other questions from the homework? Any other questions from the homework? Yeah. Did we do 4? No, but I can do it for you. Okay, 4. Y'all ready for this? All right. Too much talking. Let's complete number 4. Celine, coming to you. On this one, it says we're going to use the elimination method. I agree with that because it's all set up. So first thing, do I have opposite signs right now on my x's? No. Do I have opposite signs on my y's? Yes. I like it. Okay? So, being I have opposite signs on my y's, I should keep in the back of my mind, maybe we should eliminate the y values first. Make sense? Okay. So, I think we should get rid of the y values first. Celine, still with you. Is there a number I can multiply by negative 2 to make it 3? No. Is there a value that I can multiply by 3y to make it negative 2y? No. So I have to multiply both equations. What do you feel the smallest number that negative 2 and 3 both have in common? 6. I agree. So what would I multiply the whole top equation by to make that negative 6? 3. What would I have to multiply the entire bottom equation to make that positive 6? 2. Let's pause. Good job. Let's pause there a second. Take a look up there. Does this make sense where we're going with this problem? Okay, we're choosing to get rid of the y's. Tristan, why am I choosing to get rid of the y's? What sticks out on the y's that makes us want to get rid of the y's first?
The negative on the top.
Yes, so they're opposite sign. I totally agree. Okay? So and are they always gonna happen that way? No. But our first question should be, do we have an opposite sign on my x's? Do we have an opposite sign on my y's? If no, then you go to the next step. Yeah.
I have a question. Are you actually using the guards at the moment?
What?
I can't see that from here. I'm not wearing my glasses.
That'll be able to put the name on the
Yeah,
board.
you came up next.
Oh, cool.
See? I had Celine, and then I switched to you. I don't know yet.
I'm gonna go with 3B because it's usually.
I just did 3B last night.
That was 3B last night.
Okay.
All right,
Oh.
Tristan's still with you. We're on our adventure of finishing this problem. We're eliminating the y's because the one reason we're eliminating the y's was that we have opposite values, and then we chose to multiply the whole top equation by 3, the whole bottom equation by 2. Tristan, do I multiply that and that?
Yes.
Do I multiply that and that?
Yes.
Is that far enough, or should I go any more?
No, it's still in parentheses.
Yeah, good. Still in parentheses. All right, so this equation is going to look like 9x minus 6y equals 30. Is that okay? Tristan, we're still picking on you.
Oh,
Ready? 2 goes here. Where does 2 go from there?
to y and then to -2.
I love it. Thank you. So we distribute on both. We're going to add these two terms together. Bo, if I add these two new blue equations together, is a value going to fall out? Which one? The y. So if I add these two equations together right now, I'm going to combine this and this. That gives me 13x. These cancel each other out because they're opposite sign values. And then that's going to give me 26. Seem okay so far? Bo's still with you? Divided by 13, x is equal to what? 2? If my x value is equal to 2, yo, thank you for a little. The good news is, Megan, you're still stuck.
Oh, God.
Hey, Bo, I solved an x value. What value would I then need to figure out then? The y value, absolutely. Reese, we found an x value, okay? We found an x value right here. We need to find a y value. So I need to pick one of the first two problems which were written in black. I have an x value. You pick, top to bottom, black one, your choice.
What do we do like the bottom one? It's easier.
Okay, I like it. So Reese is choosing this. Shh. So I have 2 parentheses plus 3y is equal to -2. Reese, what was here? An x. What is now going to replace that x?
2.
A 2. Very good. So 4 plus 3y equals -2. Shh. Some of you guys are being kind of rude. You're talking a little too much. Okay? And I'm feeling really good about this because I feel a lot of you are going to do well on this quiz, but some of you are going to continue to disrupt, and that's not cool. So I wind up with an answer of 2, -2. This seems good. Were there any others from the homework we should talk about? All right, so let's move on. We did number 4 already.
Can we please do number 8?
All right, did already.
Wait, we did?
Uh-huh.
Okay.
One of my first ones.
Just.
Telling you. Yeah. Thursday. Cool? And today's Tuesday, right?
Why do we have? It's Tuesday.
So I want to make sure you guys knock this out of the park. Because I'm part of your adventure of everyone gets 5% higher than last semester.
Everybody is 5% higher than you gotta try. Rico's burrito thing.
Giddy up, dude. I'm in. I'll drip the hot ass sauce in my eyes. It'd be awesome. Number 5? If I have time, can I come back to it? Please? Okay. All right. I would like you to flip to that next page. Page 130. Because page 130, we have story problems. Oh, yes! We get to read something. We get to develop our imaginations. I love it. All right. All right. Let's read the story as you guys read along with me. Ready? The senior class is at EHS, that would be Eagle Crest High School, and CCHS, which is Cherry Creek High School, planned separate trips to Yellowstone National Park. Good, because we don't want to go with those guys.
They're frozen, so are we.
EHS filled 14 vans and one bus with 153 students. So Eagle Crest had that. Cherry Creek High School filled 14 vans and 7 buses with 483 students. Each van and each bus carries the same number of students respectively, meaning the vans, if they're all 10-passenger vans, then they're all 10-passenger vans. If the buses seat 53, then the buses each seat 53. Okay? So, this is problem number 10. We have EHS and we have CCHS. Still with me? Okay. Mac, how many students came from Eagle Crest? 153. Mac, how many students came from Cherry Creek High School? 483. Everyone still with us in this wonderful story of this trip? Okay. Now, we had buses and vans. So buses, I would say, let's use B. Vans, let's use V. Nah. BV. All right. So, Max, still going along on this adventure. How many vans did Eagle Crest use? So I have 14B. How many buses did Eagle Crest use? 1B. And so if I load everybody onto the vans, everybody onto the buses, that has to equal the 153 people that are going along on the trip. Still with us?
Yeah.
Thanks. You're no longer being picked on. You're not really. Ashley, coming to you. Cherry Creek High School had how many vans? 14 vans? How many buses? 7 buses. So if I load all the vans and all the buses, that should give me how many people? For Cherry Creek High School. Uh-huh. So if I load all the people on the vans, all the people on the buses, Cherry Creek, how many people are we bringing? 483. Okay? I see what you're doing. You're trying to count up all the vehicles, but we're not looking at a vehicle number. We know that of the vans and of the buses, there's 483. For Cherry Creek High School, Eagle Crest, take all the vans, all the buses, have 153. Okay, so, still reading this adventure. Let V equal the number of vans, B equal the number of buses. Write a system of equations that represents the situation. 14V plus 1B equals 153. 14V plus 7B equals 483. That's my system. Okay? Taking a look at this. Taking a look at this system of equations. Ashley, I just left that as B rather than 1B. Would that make sense to do mathematically? Yeah, absolutely. Okay, so again, I just wrote B as B. I didn't write it as 1B. We're only talking about a single thing. Okay, Ashley, do you feel that I could do the addition method to eliminate one of my variables pretty easily? And what should I do?
Well,
One of them has to be negative. I like it, so let's change the color on you. We're going to go, which one, top or bottom, your choice. Top? Oh, I could do -7, but I want you to look up there real quick. Look at your V's on both. So, yeah, if I multiply just -1 across, you're absolutely right. If you did -7, the B's would have canceled out, but you would add and multiply -7 here and -7 here. But if you just did -1 here to here to here, that gives me -14V minus B equals -153. And then this one stays as is for right now. which should work out nicely if I add them together. Ashley's still picking on you. Do I have opposite B values right now?
Yeah.
Yep. So if I add these two equations together, those cancel out. Okay, negative B added to 7B is 6B. I need help. What is negative 153 plus 483? You have a calculator.
3
How much? 330? 330? Okay. And it's positive. So divide by 6, divide by 6. B equals, 6 goes into that, 55. Okay. B equals 55. What the heck does that represent, Brenna? What about buses? Is that the total number of buses? No. What does it stand for, Ray? Yeah. Each bus carries 55 people. Each bus can carry 55 people. Okay? Brenna, I now want to figure out how many the vans are going to cover. So if I know that my buses take 55, I need to figure out one of the equations to plug it into. So I need to plug it into this one or to this one. Your choice, left or right? Left, I like it. So B is 55. I'm going to plug 55 in right there. 1 times 55, same thing as 55, right? So I get 14B plus 55 equals 153. Subtract 55. Help me out. What is this? What is that? 153 minus 55? 98. Divide by 14. What do we get? 7. Does that mean I have 7 vans, Brenna? What does it mean? Yeah, my vans can carry 7 people total. My buses can carry 55 total. I know that Eagle Crest required 14 vans for their trip and 1 bus. I know that Cherry Creek High School required 14 vans for their trip and 7 buses. Okay? I like it. I like it. All right. Second word problem. Problem number 11. Still on this? Oh, this is going to be good.
Oh, no.
We all got listeria poisoning, though.
It's Chipotle.
I guess we didn't want to violate any copyright infringement, so we spelt it wrong. The real reason is I'm a math teacher, and the rest of us in the department making us a math teacher, we can't spell. That's why I say X equals. All right, Preston, coming to you on this adventure. All right, word problem time. 2 groups of students order burritos and tacos. Burritos. From Chipotle. The new place. The order of 3 burritos and 4 tacos costs $28.43. Okay? The other order of 9 burritos and 5 tacos comes to a total of $69.82. Holy moly, guacamole. Oh, I like guacamole.
It's extra.
That's why I go to that other place that doesn't cost you extra. All right. So, the burritos is B, the tacos is T. Make sense? C. We're not using. All right. So, we have 1 order. Preston, we're talking about you. I have 1 order of 9 burritos. So, how would I write 9 burritos mathematically?
9B.
9B. And the other order of, that same order with 5 tacos, how would I represent 5 tacos mathematically? 5T. How much does that cost?
That cost
Oh, I did the second one actually. $69.82. Okay, still it's gonna work. Still work. All right, 3 burritos. How do I represent 3 burritos mathematically? 3B. 4 tacos mathematically is 4T, and that's equal to 28.43. Preston, still picking on you, bud. Sorry. That's our system of equations to start solving this. We want to figure out how much each burrito cost, single burrito, and how much each single taco cost. Okay? Preston, I have B representing burritos and T representing tacos. You still with me? Okay. Do you feel that I have an opposite sign of B's? Meaning was one positive, one negative? No? What about T's? No. So what I have to do is I'll need to make sure if I multiply, I'm multiplying by a negative if I only have to do a single number. Would you feel right now that it would be easier to solve or to get rid of B or T? And I'll tell you, one of the choices would be you can multiply one of the equations entirely by -3, or if you pick the other one, you'd have to multiply by 4 and 5 respectively. One of them would have to be negative. So you want to get rid of B. Which equation would I have to multiply by -3 by to get rid of my B's then? First one or second one? Up on the board. Second one. So we're multiplying this whole equation by -3. Still with me? All right, I'm going to distribute here. I'm also going to distribute here and distribute here. If you have a calculator, I need your help, please. So I get -9B. I can do that. I got -12T. I can still do that.
Yeah.
What is -3 times 2843? I know it's negative.
Negative 85.29.
85.29?
Negative 85.29.
Good. Thank you. All right. These are the two equations that I'm going to add together. If I add them together, gauge. If I add those two equations I just boxed together, do my B values fall out?
Yes.
Yes. All right. So if I add that to that, those are gone, right? 5T minus 12T is -7T. Okay. I need help with someone with a calculator. 69.82 minus 85.29. 69.82 minus 85.29.
Negative 15.47.
Negative 15.47. Okay, let's divide each side by -7. So negative over negative is positive. I wind up with T equals 15.47 divided by 7. You okay? 2.21. Negative 2.2. Double check it.
That's not right.
15.47 divided by 7. Really?
Yes.
2.21?
Divided by -7?
Negative over negative.
2.21.
2.21. T is equal to 2.21. Does that mean I ordered 2.21 tacos, Angelo?
Yeah.
Really? You ordered 2.21 tacos?
Yeah, I'm gonna go up to Chipotle
I could
and
eat
I'm like, I want.
Wait. What? How does this make sense? Does my taco cost 2.21, or did I order 2.21 tacos? Did my taco cost 2.21, or did I order 2.21 tacos? That's my cost. Would it make sense for a taco to cost $2.21?
Yeah.
I think it's a little pricey, but I guess it'll work. Okay, so if my taco costs $2.21, how would I find my burrito cost? Plug it in where? Karen, which equation of the red equations? I want to plug into which one? Your choice. Top or bottom? Top, I like it. All right, so I know my taco. I'm plugging it in right here. Got it? Still with me? All right, if you have a calculator, keep it out, please. So I get 9B plus 5. There was T there. Equals 69.82. Squeeze up there. I'm going to put 2.21 in. I need help. 1105, thank you. Subtract 69.84. 69.82 minus 1105, please. 69.82 minus 1105 is what? 69.82 minus 1105 is what? I feel like I'm talking to my wife after I feed myself. Huh? 58.77, thank you. If I divide that by 9, my burrito cost is what? 58.77 divided by 9 is? 6.53. All right, my burritos happen to cost 6.53. And again, a lot of times when you're doing some of these problems, some people are going to get confused with the issue going, how can I order 6.53 burritos? You're not. We found the cost of each burrito. Okay? We know one order was 9 burritos, 5 tacos. We knew another order was 3 burritos, 4 tacos. We found the price of each of the burritos. We still okay? Hey, all right. I think we did the. Hey, Angelo. Problem number 12. It says write a system of 2 linear equations with the given characteristics. So if you have one solution, what does the answer look like in respect to x and y? Here, I'm going to do this. You can have this for an answer. You can have this for an answer. Or you can have this for an answer. Which one of those up there would mean one solution? The first one. Okay? So this means one solution. Okay? Angelo, if we have one solution and we graph them, do they cross? Are they parallel? Or are they on top of each other? Yes. So these are crossing lines. Okay? Okay, does that make sense? So they're crossing lines. If I have one solution, that means I'm able to solve x. I'm able to solve y. There's one solution. They cross. Christian. Second one says, the system has no solutions. Which of the remaining answers would work with no solutions? Yes, this is no solution. Christian. If there's no solution, do they cross? No. Do they lie on top of each other?
They're parallel.
No, they're parallel, right? Yeah. Okay. The last one says infinite solutions. If I graph infinite solutions, how many lines does it appear I have graphed? It appears I have one line graphed, right? Infinite solutions. This is the same line graphed. Okay? It's infinite solutions. The line's right on top of it. Okay? So, guys and girls, today is what? Tuesday. Today is Tuesday. Okay? So, we got this taken care of. Wednesday, we are going to have some review in class. Still with me? Thursday, we're going to do a quiz. Our quiz will consist of graphing, solving when they graph, substitution, solving with substitution, and elimination, solving with elimination. Your assignment for tonight, if you choose to work that hard, is...
Is that like Mission Impossible?
Wait, Mr. Straub?
Yo.
The graphing on the graph, you have a test of the quiz.
What about it?
The graphing for the quiz.
Yes. And I will go over some of that tomorrow. Hey, you're on camera. All right. Guys and girls, your assignment for next time. Worksheet number 4. 1, 4, 7, 10, 13, 16, which is the left column. Sound good?
Yeah.